Hello, Dr. Manjeet.
Hello, very good morning, sir.
Yeah, good morning. Good morning. Yeah. Hi, Dr. Singha.
Good morning, sir.
Hi, hi,
Hello.
hi. So, how are you, Dr. Nitin?
I am fine, sir. Just excited to interact with the participants.
Yeah. Welcome in this session. Yeah.
Okay, thank you. Thanks a lot.
Okay, Dr. Nitin, can we wait for 5 to 10 minutes? Let participants come online.
Yeah, sure, Dr. Manjeet.
Okay, sir. I will inform you when participants will join this session.
Yeah, sure.
Okay, thank you.
Yeah, Dr. Singha, yesterday Dr. Abhay was with us from IIT Roorkee. Yeah. Dr. Singha, am I audible to you?
Dear participants, we are going to start within 5 minutes. So kindly stay there. And we will come back at 9:40. Okay, so we will start at 9:40 anyhow. So we are waiting for other participants to come, and after that we are going to start. Thank you. Okay, hello dear participants. Very good morning to everyone. I greet all of you on the behalf of NIT Jalandhar. So it's a great pleasure for me to introduce you our speaker for today's morning session, Dr. Nitin Singh Singha from NIT Delhi. So today's speaker is going to share the knowledge about blockchain with us. He is going to introduce you blockchain and going to discuss the various challenges that currently we are facing while doing the research in this field, and also going to enlighten us about the various applications, or you can say the future applications of the blockchain. So before call upon the speaker for today, I want to give a brief introduction of today's speaker. So, Dr. Nitin Singh Singha, right now, he is a faculty member of NIT Delhi. Before joining the NIT Delhi, he was the faculty and the head of the electronics department in IIIT Kurnool, Andhra Pradesh. As and about his academic qualification, he has done PhD from IIT Kanpur and MTech and BTech both from NIT Hamirpur. And after graduating, after doing the BTech from NIT Hamirpur, he has worked in multinational companies like Wipro and Cisco. And again, he came back for MTech in NIT Hamirpur. While doing MTech, he has qualified Indian Engineering Services in 2012 and secured 47th All India rank. And while in 2012 also, his GATE score was very high, and he was the in the top 200 in GATE 2012. And after that, he has moved to IIT Kanpur to pursuing his doctorate. And after completing doctorate, he has worked in IIIT Kurnool and came back to the NIT Delhi. So there are lots of things that about the today's expert, and we are short of time. So I call upon today's expert, Dr. Nitin Singh Singha, to share their knowledge with us. So, Dr. Nitin.
Thank you, Dr. for the introduction. So, good morning, everybody. So, I am sharing my presentation on blockchain. Is it visible to everybody?
Yes, sir, it's visible, sir.
Okay, thank you, Dr. Manju. So, participants, I will try to have a generalized discussion about the blockchain. I'll not go into much more details, technical details about the blockchain, but what I want from you is that your active participation. You can either unmute yourself and participate, or you can write on the chat box, right? So it's more of a very generic, and I'll try to make it as generic as possible, and I hope that you will be able to understand it. Okay, so start with since it's a technical FDP workshop, I will just discuss about briefly about the inventions that changed the society. So starting with it, then we will correlate it to the blockchain. So to start with, inventions that changed the society. So the first invention was printing press, discovered in 1400 BC. Now, how printing press changed the society? Now, printing press filled the knowledge gap. Before invention of printing press, the knowledge was being transferred from one generation to another using oral communication. So that was also the reason that knowledge was getting accumulated to one particular section of the society called Brahmins. They did a great job, but it was getting accumulated to Brahmins only. But after printing press was discovered, we started actually printing whatever research we were doing or whatever, like Bhagavad Gita, our religious text, scientific text, everything was we could print easily, which led us, which led the information to disseminate to every section of the society. So that is why this printing press is one of the invention that changed the shape of the society. Now the next invention that changed the shape of the society was engine or machines, which were discovered in 1800. Now, how engine changed the shape of the society was that the most of the tasks, especially slavery tasks, which did not require human mind, were slowly transferred to the machines. For example, you might have seen in the movies, there is human tanga. It used to exist in 1800 when Britishers were there. You can, if you browse through the history, you can see that human tangas were very popular in West Bengal, in Shimla also, the summer capital of Britishers. It was very popular. Now we never see human tanga. We have autos and everything. So with the advent of machine, the slavery system was abolished. Every human being became equal in the society. One of the prominent reasons for abolishment of slavery system was the advent of these machines. So that is why I'm saying that engine is the is an invention that changed the society. Now the third thing, the most recent thing that changed the society is internet. Now internet has drastically changed the society. One of the example is distance gap. So you can see that with the advent of this internet, I am sitting here at Delhi and communicating with the participants, which are spread throughout the India. And this is a very small thing. Sitting here, I was talking to somebody in USA day before yesterday. So you can see how internet has reduced the distance gap. Then this internet has created many billionaires also. Mark Zuckerberg, then Bill Gates. All these billionaires have been created by internet because of the invention of the internet, right? So this is also one invention that changed the society. So in this talk, I will discuss about a technology which will, don't take it as a you are learning a technology. Take it like this opportunity to learn something which can make you a billionaire like Zuckerberg and Bill Gates, right? So before continuing further, I would like to ask you that can you tell me what do you think will be an invention in the nearby future which can change the shape of society, like printing press, your machines or internet? Can you think of any invention? Just random guesses. Yes, Mukesh is typing AI autonomous vehicles. Yes, but these are some of good. These are some of the examples. Can they make you billionaires? Yes, absolutely correct. AI is one of the inventions. Autonomous vehicles are also good. Any other thing? It's nice that audience are responding to you. The very good audience are there. Usually I do not get more than one or two responses. So good. So now one of these invention is in this 21st century is trust. trust that will be sold in this society. That will change. One of the, apart from AI, data science, autonomous vehicle, trust is one more thing. And I think people can earn a lot using trust. They can actually become billionaires using trust. What do I mean by trust? I'll give you one example. Nowadays, there's a hype in the society about the organic farming. Like, so a normal apple or a normal any vegetable, if it cost 30 rupees per kg, and if they put a label that it's an organic vegetable, its cost becomes 2 or 3 folds. You might have seen this thing. It may become that the same vegetable, if they put organic farming, it becomes 90 rupees. But such sort of business is not gaining much popularity. The reason being, you don't know whether actually it is organic or not, right? So actually, people are actually making huge amount of money using this trust. I give you an example. One of my friend is an orchardist, apple orchardist. So I will not name the retail owner, retail company. He told me that this retail company is procuring apple at 20 rupees per kg from the farmers, and selling it in the market to consumers at rupees 250 kg. Yes, farmer deficit is also a trust deficit. The example I am taking is close to it also. So they are selling it at 250 rupees kg. This company is doing nothing but just putting its label on the apple, and people are purchasing it. Why? Because this is I'll not name the company, it's a retail giant, and people trust it. So it is earning more than 200 rupees just on its reputation or brand name, trust. Right? So that is why I'm saying this trust can make you billionaires. So it's like it is Kalyug. In Hindu mythology, it is called Kalyug. In Kalyug, nobody will trust anybody. Right? So if you can establish a system where you can trust, you can earn billions and billions of money on the basis of trust. Right? So that is what our talk will be all about. Today's talk will be centered on trust. Now, one more example I would like to give you about trust is whenever you purchase branded clothes, branded shoes, an Adidas branded shoe, which cost 10,000 rupees, actually the total, its production cost is less than 2 or 3,000 rupees. The remaining 8,000 rupees, company is earning on its trust. People trust brands because they follow strict policies that their product is free from any fault, right? So they are just selling you the trust, right? So this trust is very important in today's society. Now, how to earn this trust? Well, how to earn this trust? How to establish a system? Let's come back to this apple which is getting showed on the screen. So, how to establish a system like a bar system where just by clicking on the bar of the apple, we will come to know whether it is organic or not. If you can trust the seller that, or trust the system that yes, it is an organic apple, I'm sure most of you will be ready to pay higher price of apple also. But since you don't trust the system, you don't pay for organic apples, higher price for organic apples. But can we establish such sort of system? Well, the answer is yes, we can establish such sort of a system. By how? One of the ways is blockchain. Blockchain, if used smartly, it can make you billionaire. It can earn you trust. How blockchain can, well, to understand how blockchain can you earn your trust, you have to first understand what a blockchain is. I am providing you a very basic definition of blockchain. It's more complex than that. I'm providing a very oversimplified definition of blockchain. So, what a blockchain is? You can say that blockchain is a sort of a magic book. It's a magical book. So, what's so magical about this book? This book cannot be destroyed. This is the first associated with the book. The second magic associated with the book is whatever you write on this book is always truth. You cannot lie and you cannot write anything wrong in this book. This is the second magic. Third magic is whatever you write on the book is permanent. You cannot change it. It has become permanent. So this is the third magic associated with the book. And the fourth magic associated with the book is that those who have authority can only read data from the blockchain. Others cannot read data from the blockchain. So these are the four magic associated with a book called blockchain. So that is why it is called a magical book. So how this magical book will help us get trust of people? Let us come back to this Apple example. Suppose this barcode is related to a blockchain, right? So you know that the data seller is selling a Apple. He knows that data cannot be destroyed because blockchain has certain sort of magic. So he will readily agree to install blockchain or to be a part of a blockchain network. We as a consumer know that blockchain is a magic book which cannot lie. Why it cannot lie? Because you cannot enter wrong information on blockchain. This is the magic of the blockchain. And the second magic of the blockchain is that whatever information is written in the blockchain, it cannot be changed. So because of these two magic associated with the blockchain, that it cannot lie, blockchain has earned the consumer trust, right? So using the blockchain, we can use to sell organic apples also. So what I will deal, so this is the very generic definition of the blockchain. So what we will cover in today's presentation is that how do we achieve such magic in the blockchain? That how can we arrive at such magical properties of the blockchain? And then I will discuss that where can you apply the blockchains? What are the generic areas? So this will help you to continue your research in those areas. And it will also help you to write projects, government projects on these areas. Government are giving nowadays DST, MITI, Department of Science and Technology, MITI, they are giving thousands of projects on the blockchain. So if you see the government circulations, they have actually sorted out some high impact areas where government is very interested to promote those areas. Blockchain is one of those areas. So blockchain can help you get projects easily, right? Now to start with, I will come to one by one each and every magical property of the blockchain, which technology is being used to arrive at this magical property. Now the first property is blockchain cannot be destroyed. Now why blockchain cannot be destroyed? So I was going through your browser. So I think yesterday there was one session on peer-to-peer networks by Dr. Satish Awasthi. So the properties of the peer-to-peer network is being used here to make blockchain indestructible. Any guesses, audience? How blockchain can be made indestructible? I have given you an idea. We can use peer-to-peer network property here. Any guesses how it can be made indestructible? You have a book, you have a record which is indestructible, which can never be destroyed. It's a very good quality. Any idea? Okay, no issues. Yeah.
Because it lies with all the nodes. Because
Yes.
whatever we are doing in one node, it will be replicated in other nodes. So no one can.
Absolutely correct answer, sir. Absolutely correct answer. So why blockchain is indestructible? Because blockchain follows distributed architecture. It's a distributed ledger. What does a distributed ledger mean? To give you an example of a distributed ledger, usually the model that we use to store the data is that we have a centralized database where data is stored. Whosoever needs the data, he can get the data from the centralized database. This is the traditional method of saving the data. For example, your library database. So you have a dedicated library server in your institute, which will store the details about all the books in the institute, right? Now, the problem with this database is that it can be destructed very easily. Somehow you manage to delete the data from the central database, or you are able to destroy the central database, then the data will be destroyed. Now, to make our system more robust, or to make it indestructible, blockchain use the property of peer-to-peer networks. What they do is every member, usually in most of the blockchains, I'm not talking about every blockchain, most of the blockchain, every member has the copy of the blockchain, right? So even if, so suppose there are 100 members, even if you are able to destroy your blockchain from one member, then also 99 members still have the copy. To destroy the complete database, you have to destroy every member of the blockchain. For example, Bitcoin is a very common network. So you know that the complete copy of the Bitcoin is a cryptocurrency which is based on blockchain, is available with minimum 10,000 nodes. So to destroy Bitcoin database or to destroy Bitcoin book, Bitcoin is nothing but a book which contains transaction records. We'll come to it later on. To destroy Bitcoin, you have to destroy its 10,000 copies, which is practically impossible. We can also prove it mathematically. For example, let the probability of failure of one node is 1 by n. Failure of one node means the database is destroyed on that node. Node is one database. Suppose there are m number of nodes or m number of databases. So the probability of failure of m nodes will be 1 by n raised to power m. The probabilities will get multiplied because the failure of database on one node is independent of the failure of the database on the other node. So they are mutually independent events, so probabilities get multiplied. What I want to tell you here is, suppose the probability of failure of one node is 0.5. Suppose it is 0.5. Take an example of Bitcoin. So in Bitcoin, there are more than 10,000 copy. So 0.5 raised to power 10,000, the value will come out to be 0.5 raised to power 10,000, the value will come out to be almost zero. Try it on your calculator. Any value less than 1, if I raise to it, if I multiply it many times, it approaches zero. So this is how the first magic is created in the magical book called blockchain, right? So like I told you, what is a blockchain? Blockchain is a book which stores record. Blockchain is a book which is used to store record. There are few magics associated with the blockchain. The first magic is the book cannot be destroyed. And how we achieve this magic? By maintaining multiple copies of this blockchain book usually at all the members in the blockchain, right? So this is how we achieve the first magic. So like I told you earlier also, I will give you a very generalized overview of the blockchain so that you can apply blockchain to your research areas. You can get the projects easily. So implementation, it is easily available. There are many companies like Ethereum is there. Many companies are there. Bitcoin is there. IBM is providing its own blockchain network. You need not to go into technicalities of the blockchain. Blockchain is like a salt. So if you are writing a paper is like preparing a dish, food item. Blockchain is like a salt. It's on your own. You will not be doing any research. You will be just modifying whatever you have prepared. So to make food more tasty, you add salt. Similarly, you might have created something. If you try to add blockchain, its value will increase many times. So that is why I'm not going into details, complex details, because time is very less. So now coming to the next property, why we can't write anything wrong on the blockchain. What is the reason why we cannot write anything wrong on the blockchain? If you see the figure, for example, I'll give you an example of Bitcoin. Why we cannot write faulty transactions on Bitcoin? Suppose I transfer 100 Bitcoins to any person. So that will be recorded in the Bitcoin's blockchain. Bitcoin's blockchain is nothing but a sort of a register, storage register. So there are different steps of verification involved before you finally write it in the blockchain. So there are set of nodes called verifier, which will actually verify your transactions. That okay, whatever one is claiming, is he claiming its claim is correct or not? This is one round of verification. Then there is a miner node. Miner is a node in the blockchain which actually writes something on the blockchain. You cannot randomly write on the blockchain. There is one designated node called miner, which actually writes on the blockchain. So then miner will do the second round of verification, right? So then only you can write on the blockchain. So what I want to say is why you cannot lie on the blockchain, because there are number of verification steps involved before actually writing on the storage register called blockchain. So that is why we cannot lie in the blockchain. And one more thing about the blockchain is that the verifiers, there is no one verifiers. There is collection of verifier. So even if one or two verifiers are compromised so that they try to write a wrong information, others will stop them from writing this information. In fact, it is claimed that blockchain can be hacked. I'm not saying that you can never write you can never write a wrong information on the blockchain. You can write it, but then 51% of members of the blockchain needs to be compromised. So take an example of a Bitcoin network. So in Bitcoin network, there are lakhs of members. So 51% member means you have to compromise 1, 2, 3, 4 lakhs of members, which is actually a very arduous and practically or virtually impossible task. So that is why in blockchain you cannot write wrong information, right? So this is the second magic of the blockchain. Why it can only store truth? The reason being that there are various level of verifications before you actually write something on the blockchain, right? And these verification steps do not involve a single user. It involves many users. So even if one of the user or two of the users or some fraction of the users are compromised, you have to compromise majority of users before you can actually write something wrong on the blockchain. Since large number of users are involved, you cannot write anything wrong on the blockchain. So this is the reason why you cannot write anything wrong on the blockchain. Now the third thing, or the most important part, is that even if you write truth, however, if blockchain is temperable, then there is no point of writing the truth. So we have to make blockchain or blockchain storage untamperable. That once anything is written on the blockchain, it is permanent on the blockchain. Then only people will trust you, right? So again, I am coming to that Apple example. Somebody wants to purchase an apple, organic apple. He wants to spend more than double on the organic apple. He should be sure that this apple is organic. How? We have a record which cannot be tampered, which is a permanent and which claims that apple is organic, right? So we have to inculcate a property in the blockchain that the record is not tamperable. So how do we inculcate this property? This is the most interesting property of the blockchain, and I would like you to pay attention to this property. This is done by chaining. That is why the name came blockchain. So using chaining, we actually make blockchain untamperable. So what we do is, again, I am taking an apple example. Suppose farmer wants to grow an organic apple. He wants to create a record for an organic apple. So how he will do is, the first step is he will get an organic certificate for its. He will submit an organic certificate of the land on which he is growing an apple. He has to submit an organic certificate. Organic certificate means that he is not using any pesticides, etc. He has not used any pesticides for last 2 or 3 years on the land on which he is growing the apple, right? So he will submit the organic certificate on the blockchain, right? So now this you can see on the screen. There is an example. You can see on the screen that this is how database looks. So the first term farmer tells me that who is submitting the certificate. The second term 001 is there, right, which tells me the sequence of the record. This is the first record being recorded pertaining to whether the apple is not organic or not. Then the third thing here in the record is what he is actually submitting. Fourth is the date of the submission. And the fifth thing is the key. Now, you can see the first 4 things in the record match the normal record. Suppose normally you are trying to record anything. What you will record? You will record who is submitting the record. What is the record number? You will provide a record number. And what actually is the record and the date at which the record is created. Now see, we are adding one additional term in the blockchain. We add one additional term which is called key. So now what actually is the key? Now key is the hash of this record. What does hash of a record means? Hash of record is like fingerprint of the record. What I mean by fingerprint of the record is that like human beings, we have a fingerprint. It is unique to every person. 98% time it is unique. So if you change the fingerprint, if you change the fingerprint, then what will happen? The person will not match with the fingerprint. Fingerprints are unique to the person. Similarly, hash or key, just remember key. This key is unique to the record, right? So what will happen is, if you try to change anything in the record, the key will change. Now remember about this thing. The key is like your fingerprint. Just remember this, because this key will help us to make record untamperable. This key will help us to create chain. And I will show you how using this chain, the record becomes untamperable. Please pay attention here. Up till now, I'm asking, the concept of key is clear or not, class? Please type yes or no. The concept of key is clear or not? Thank you. So only one has typed. I think, okay, 2, 3 are typing. Good. I think there is delay of internet delay. So that is why I am getting responses. So key corresponds to uniqueness. So if I try to tamper the organic record, the key will change. Now I will show you how this key forms chain. Now suppose farmer has submitted that it's an organic, that it has not used any pesticide on the land in which it is growing apple. The second record that farmer is submitting is that he has not used any genetically modified crop or apple. Why? Because some people are reluctant to use genetically modified crop. Now the second record that he is creating. So again, for the second record also, he will create a key alongside the record, alongside the conventional record. Conventional record corresponds to record without key. But for the second record also, it will create a key. But this key is a function of the second record, which is genetically modified, and the key of the first record. Right? So when I am generating the key for the second record, what are the inputs that I am giving? The parameters of the second record plus key of the first record. So that is how these two records are getting interrelated to each other. Do you understand how? Now you understand how we are chaining the records. We are actually trying to bind the records. So what is happening is, when I am trying to generate the key of the second record, so apart from the second record that I am inputting to generate the key, I am also using the key of the first record to generate the key of the as the input to the key of the second record. Now in this way I am doing chaining. How chaining? What does I imply by chaining is that suppose I have two records. I have generated second key. Now if I try to modify first record, will the key to the second record change or not? If it changes, why it will change? I want you to understand what is chaining. Now I am saying that when I am generating key to the second record, what are the inputs that I am taking? Second record plus key to the first record. So my question is, if I try to tamper first record, whether there will be change in the key to the second record or not? Yes or no? Okay. Some are saying no, some are saying yes. Good. So yes, the answer is yes, there will be change in the key to the second record, key pertaining to the second record. Why? Because you see, when I'm generating key to the second record, what are the inputs that I am taking? The inputs are the second record and the key of the first record. Right? Now what will happen is, if I change the first record, its key will change. Key pertaining to the first record will change. Now this key is being provided as an input to generate the second record. Now since first record's key is changed, second record's key will also get changed. So this is how we are chaining the first record to the second record. Similarly, now coming back, now suppose the third record that farmer is submitting is that he's saying that after growing apples, he has not used any pesticides. Right? This is the third record he is submitting. So the input, so I want to generate the key for the third record. So the inputs will be the third record plus the second record key. We use the key subsequent to the current record to generate the key for the current record. Right? Generating key for the third record, the input will be key to the second record and the third record itself. So in this way, these three records are chained to each other. Now you see here again also, same thing happens. Suppose if I try to change first record, the key pertaining to the third record will also change. Why? Because first record changes key 2 and key 2 changes key 3. So there is a chaining effect. So that is why it is called blockchain. So now coming back to the, so now you see here, so after farmer has submitted all the certificates claiming that he has not used any pesticides, he has used organic farming methods, and he has not used genetically modified crop, the government agency will again conduct a soil testing, which will get added to the record, right? So after that, farmer will submit the date of harvest. Then retailer will record the date of purchase, and the fruit seller will provide you date of arrival. So when you try to purchase this thing, when you try to purchase apple, maybe you can have a barcode type of system. You scan the barcode, you will get all the information. Right now, you don't have to check each and every information. You have to check only the key to the seventh record. Why? Suppose I'll give you an example. Suppose because all these records are chained to each other. So if I make changes anywhere in the record, key to the seventh record will invariably change. For example, government conducted a soil test, right? So farmer tried to change soil test. What will happen? The key to the fourth record will change, right? Or suppose a retailer, fruit seller try to change the fourth record. What will happen? So key to the fourth record will change, which will change the key to the fifth record, which will subsequently change the key to the sixth record, and finally the seventh key. The seventh key will not match. Suppose fruit seller has changed the key, so in the record the seventh key will change. And similarly, we already know the record of blockchain is distributed everywhere. There is some government record, so both the keys will not match. The key to the seventh record with the fruit seller and with the government will not match. So as a consumer, you just have to look at the final key, right? You just have to look at the final key. Seventh key you will see the seventh key is not matching. You will see that record has been tampered. Okay, I will not purchase this apple because this record has been tampered. Is it clear? So what happens in the blockchain? Is it clear how chaining is being done in the blockchain? Class, again, I will give you a brief idea. So what we do is, as compared to traditional record, we maintain a key for every record that we are entering in the blockchain, right? Now this key is being transferred to the next record also, so that even if you try to tamper the current record, it will get reflected in the next record, and the chain gets breaked. That is what I have showed here. Because in this figure, if you see here in the slide, I tried to change the fourth record. So the chain got broke because of changing fourth record, changed its key. This key is being provided as input to the fifth record. Now the fifth record key will change, the sixth will change, and the seventh record key will change. So there will not be the consistency in the database. So the person who has made the change, his database will be different from other people's database. So you can easily figure out whether some changes are, whether the record has been changed or not. So one of the participants has asked how much time it will take. If we change the key, then how much time it will take? It depends upon the type of blockchain you are using. If you are using a very heavy blockchain, it may take more time, right? So it depends upon the context of the blockchain. Then I can give you a more precise answer. In the blockchain to reflect this change. In the current database that is with you, it can take in few seconds. But if you want to propagate that change to the throughout the network, then it will take some time depending upon the length of the network, right? So in this way, the records are chained to each other. You try to make change in one record, the subsequent records will be changed. So that is why it is called blockchain. Now, class, everything understood about what is chaining process in the blockchain, why records cannot be manipulated. If you have any questions regarding that, please ask now, because this is one of the very important aspects of the blockchain. So it should be very clear. So that is why I am not claiming that blockchain cannot be hacked. What I am claiming is it's very difficult to hack the blockchain. It's virtually impossible. It's very difficult. It's like that every law can be broken, whether it is a Godrej law or some other company's law. The amount of effort required changes, right? We cannot have any lock which cannot be broken. Similarly, for blockchain also, it can be tampered, but it's almost impossible to tamper. You will require a lot of effort. I'm not going into technical details. Otherwise, there is one analysis, Bitcoin analysis available, which says that the amount of effort that will go in tampering the Bitcoin will be more than the utility received after tampering. What does it imply? Suppose you want to tamper, you want to add 10 rupees in your Bitcoin or 10 Bitcoins in your account. So the amount of effort required to add 10 Bitcoins will be more than 10 Bitcoins. So that's why people are not manipulating Bitcoin. So what I mean is blockchains are designed such that they can be tamperable, but analysis have shown that the amount of effort required is more than the utility earned by tampering it. So that's why we assume that blockchain are not tamperable or they are not hacked. So Mukesh has asked one question that storage capacity required in network is high. Yes, storage required in the blockchain are very high, and there are certain networks in which coming to the storage, I'll tell you. So you see, you talk about Bitcoin. I'll give you an example of Bitcoin analogy to clear your doubts about Bitcoin. So Bitcoin, millions of people, or you can say lakhs of people are using Bitcoin. So usually storage in GPs will be required to Bitcoin. So if I want to have a Bitcoin network, or if I want to be part of a Bitcoin network, I have to install Bitcoin application on my computer. So I cannot dedicate GP storage to a Bitcoin. So what usually they have done is, what they have done is that there will be certain users called full nodes, which will have the complete copy of the Bitcoin network. They will dedicate GB units of storage to the Bitcoin. And the normal users like us, for them, we have to only provide storages, dedicate storages in MB only. We need to store our own records only, our own records of Bitcoin. Understood? So they have segregated Bitcoin has segregated the members. There are full nodes who will store the complete Bitcoin network details. They are approximately 10,000. So they have to have GB's unit of storage available in the PC. And there are normal users like us, which are using Bitcoins. So we need to store our own records only. So we need to dedicate only MBs of our storage. So depending upon the blockchain, and there are customizable blockchain also. So depending upon that, what type of user you are, what type of blockchain you are using, the storage capacity depends upon these factors. Is it clear? Now, storage, somebody has asked how much storage is required for hash. It is 256 bits. Blockchain uses SHA 256 hash algorithm. there are hashing algorithm. Hashing algorithm means how you are generating fingerprints. I'm not going into details, I told you earlier. So 256 bits are required to store hash in the blockchain. Remaining is your data. Okay, I hope so your doubts are clear. So let us move forward. Is there any other doubt regarding chaining? You can ask, participants can ask if there is any other doubt regarding chaining. So, since I am not receiving any questions, so I assume that you have understood the three aspects of the blockchain, three magical aspects of the blockchain. First aspect is blockchain cannot be destroyed. Second aspect is blockchain, you can only write truth in the blockchain. And the third aspect, magical aspect of the blockchain is whatever you have written in the blockchain cannot be tampered. It's truthful. Now, before going further, what I want to tell you is, since time is very less, 1.5 hours, I'm giving you a very generalized overview of the blockchain. The actual working of the blockchain is maybe different from what generalized overview I am giving you, because it is impossible to cover each and every aspect of the blockchain in 2 hours. It will require me at least 6-7 hours. So it's a generalized overview. It will help you understand the basic operation. So you have to study blockchain in somewhat detail, then you will understand the actual working of the blockchain. For example, like I am discussing chaining process here. So I am generating key for every transaction and then linking the transactions. Actually, in blockchains, we do not store transactions like this. We store group of transactions and then generate a key, which is we store group of transactions called block, then generate its key, and this key gets transferred to the next block, right? But the general idea in the actual blockchain and the chaining procedure which I have discussed here is almost same, right? So moving forward. So the next thing that I want to discuss is authorized access. Now, what do I mean by authorized access is you have your bank records, right? So nowadays, do you want that your bank records should be available to all? Do you wish or you want to hide your bank records with others? Are you okay that your bank records are your bank account details, like how much amount of money you have, how much money you have spent on something items? Should it be available on public domain or not? This is my question. Participants? No, yes. What about others? Should it be available or not? Yes, but I'll tell you that the whole complete blockchain or Bitcoin network, to make it what you'll say distributed and to earn the trust of the user, the whole details are available on the internet. For example, but you details are available, but you cannot see them. For example, I'll show you one site where blockchain details are available. I'll just share you the site and show you how the blockchain details are available in the public domain. Even though they are available, but you will not be able to figure out who is what, who has done what transaction. There is a site, if you can type blockchain explorer and log into that site. I'm sharing the site with you. So once again, I'm logging into blockchain explorer's site. This is the database of the Bitcoin. To earn the trust of the users, Bitcoin has shared its database with everybody in this whole world. Everybody can access this database. So is the blockchain.com visible to you on the screen, class? Yes or no? Please type yes or no. I have shared blockchain Now see here, see the video. Like I told you, these are the blocks. I told you in the blockchain, not a single transaction is not stored. A group of transaction is stored. So this is one transaction. So I'm entering that transaction. This is one of the transactions. I'm entering that transaction. Now you go to the records. These are the records actually. One of the guy has transferred 7 bitcoins. BTC means bitcoins to some other guy. Then there is second record. In the second record, one user has transferred zero point 0.8 bitcoins to the second user, right? But can you figure out? But can you figure out that we are not able to understand who is transferring to everybody, right? So this is, yes, Mukesh is right. This is done using encryption. So using encryption, we are encrypting our records. Even though our records are available on the public domain, not everybody can access it. Why this is so important in blockchain? Because blockchain means distributed database. Your database is available with every member. If you do not encrypt the database, everybody will know what you are doing in the blockchain, right? Like I told you, Bitcoin database is available with everybody. It should be available with everybody. Otherwise, because it's a distributed database, it should be available with all the members. But if it is available with all the members, and then your records are available, your records are compromised. To avoid this thing, we store the records in the blockchain, but in an encrypted fashion. So the next part is how we enable authorized access. We are talking now about the last magic of the blockchain, which is authorized access. How do we enable authorized access in the blockchain? That we will study now. So coming back to the presentation. So first of all, I would like to tell you so somebody is asking me that why Bitcoin transactions per second is slower than Visa. So the answer for this thing is that in blockchain, I told you we have to verify the transaction before it is submitted. So the verifiers involved in the blockchain is not a single machine, but a group of machines. And there is no one-step verification. There is a 2, 3 or more steps verification, due to which the transaction time for Bitcoin is less as compared to the normal Visa or MasterCard, because of the rigorous verification that is involved in the blockchain. So anything that is put on the blockchain or recorded on the blockchain has to be verified first. The verification process is very rigorous. And one more reason is there is no central authority also in blockchain which can verify it, right? Like in banks, Visa usually, when you go for Visa or MasterCard transaction, there is a centralized authority called bank which can verify the transaction easily. But in blockchain, there is no concept of centralized authority. There are group of nodes which work together. So whenever there is no centralized authority, it take some time for consensus to arise, right? So that is why the blockchain transaction is very slow. And that is why Bitcoins and other things are not becoming popular also. Paytm has become popular. PayPal has become popular. But blockchain is not becoming popular. The only reason is because it is taking seconds and sometimes minutes to commit a transaction on the blockchain. So now coming back to the presentation, the last magic of the blockchain, that why there is how authorized access is achieved in the blockchain, how encryption is achieved in the blockchain, so that even though everybody has a copy of the database, but the only one who has the permission can see the record in the database. Now, to achieve this encryption, we need to understand the concept of public and private key. So I'll take you a very simple example to tell you what a public key is and what a private key is. I think most of you will know, but since Department of EC is conducting this seminar, so there are many EC students who do not know what a public key is and private key is. So we'll take a very simple example to understand it. So now public key means that this key, so every machine will have two keys, public key and private key. Private key is with that machine only. That is, it is private to that machine, only that machine. Suppose there is a machine A, it will have a public key and private key. Now the private key will be known by machine A only, whereas public key will be known by all the machines in the network, right? So in this way, we allow authorized access. How? I'll tell you. So suppose we take an example. There are two schools adjacent to each other, right? One is girls' school and one is boys' school. Now the authorities of the school, they are very particular that girls in the girls' school do not interact with the boys in the boys' school, and boys in the boys' school do not interact with the girls in the girls' school. Please understand the example. We'll understand public and private key by a general discussion. So please understand. So there are two schools. Girls are not allowed to interact with boys and boys are not allowed to interact with the girls. Now, to make things more difficult for students to interact, they are not allowed access of Facebook, WhatsApp also. They are not allowed to keep mobile phones also. So it's an old-fashioned school, and students are not allowed to keep access of phones and everything. The only thing is there are barbed fences between the girls and boys schools hostel. So girls can see the faces of boys and boys can see the faces of the girls. They are not allowed to make any gesture. If they make any gesture, they are immediately reprimanded. Right? So this is the scenario. And suppose there is a girl called Ria in the girls' school. And from the barbed fences, she can see two boys, suppose Karan and Abhishek are two boys which are there in the boys' school hostel. She can see them, right? And she figures out that they are interested in her and she wants to communicate with them. So how can she communicate? Why communication is difficult here is they cannot talk. If they try to talk and they are caught, even though they are barbed fences, they will be immediately rusticated. They have separate hostels, separate classes, separate playgrounds, but there is one glitch. They share the common library, right? They share the common library but timings are different. For example, girls are allowed in the library in the morning and boys are allowed in the library in the evening. So can you, in this scenario, participants, I want you to figure out ways so that Ria can communicate with Karan or Abhishek. Can you tell me a scenario how they can communicate? They are not allowed to talk to each other. They cannot use phone. Any responses? You don't use any hi-fi technology, just common sense. And then we will relate it to the public and private key. So Vinith is writing letter. Yeah, Vinith letter is there, but there is a risk with the letter. Suppose Kunal wants to write a letter to Ria. Kunal writes a letter, leaves it in library. So next morning, if Ria comes and she sees the letter, that's okay. The communication will be established. However, if somebody else sees the letter, they can report it to the school authorities and Kunal will be rusticated. So writing a letter is a very difficult task. So now Kaushal is saying that, Mr. Kaushal is saying that you can write a letter and put it in a place known to them only. But that could have been possibility if Ria and Karan had interacted with each other at least once so as to decide on the common place. They have never interacted with each other. So, how can they decide on the common place? Yeah, they can make a code word, but before making code word, they have to interact with each other. So, I'm saying this is the first interaction. So, how can they do it? Any more ideas? These are good ideas, correct? Mr. Weber, Mr. Kaushal, Mr. Vineet have shared great insights. Any other participants? Come on, guys. In the school, you might have tried to approach a girl or a boy. I think you are much better than these tries. So, since the time is less, I will give you an example. What Ria can do is she can purchase a box, right? So the box, when it is open, when it gets closed, then only Ria has the password to open the box, right? So what it will do is Ria will place the open box in the library. Now Karan can write a letter, put it in the box and close it. Once it is closed, nobody can open it except Ria. So even if the box is caught, Ria or Kunal will not be reprimanded by the authorities because they do not have a proof that Karan has tried to approach Ria. Is this scenario clear? If I have a box with a code word, then it can be done very easily. Now, how it is related to public and private key? Now, the code word of the box is the private key of Ria, and the open box is the public key of the Ria. So anybody can write. So when I'm closing the box, so anybody can use the public key. This public key, the open box, is available to everybody. So this is what is the difference of public and private key. So whenever in the blockchain I want to write anything, right? Suppose A has transferred money to B, or anybody is writing some record pertaining to some other node. It will encrypt it with the public key of that node, so that only that node can encrypt that data. For example, suppose Alice wants to transfer something to the Bob. Now Alice has public key of Bob, but not its private key, right? Just see here how this encryption is done in the blockchain. Wants to transfer something to the Bob, and Alice wants that only Bob can see that data. So what it will do is, it will encrypt the text that it wants to transfer to the Bob with the public key of the Bob. The public key of the Bob is available throughout the network. So the encrypted text will be transferred through the network. Now suppose within the network, Eve is the bad guy. Eve gets hold of the encrypted text. Even if Eve gets hold of that encrypted or cipher text, it will not be able to decrypt the text. Why? Because only Bob has the private key to decrypt the text. Now remember, there is one concept of public and private key. Now public and private key are dual to each other. What does it mean is, suppose if I encrypt any data with the public key, then it can be decrypted only by the private key. Similarly, if I encrypt anything with the private key, it can be decrypted only by the public key. So suppose I want to send some encrypted message or write some encrypted message. So what I will do is, suppose I want to write an encrypted message on the blockchain so that only user A can understand it. So what I'll do is, I will encrypt that message with the public key of the user A. So anybody can see the message. For example, the blockchain records that I have shown you, they were hash number 0012HF. They have been encrypted. We can see them, but we cannot decrypt them because we do not have corresponding private key for that messages. Right? Class, so participants, this is all about how we achieve the four magics in the blockchain. The four magics are: blockchain cannot be destroyed. First magic. Second magic is that you can only write true values in the blockchain. The third message is that whatever written cannot be tampered. And the fourth message is that everything is encrypted, so that only those who have authorized access can see the messages in the blockchain. So I have provided you the brief overview about the technologies being used in the blockchain to create that magics. So blockchain is not a new technology. It's just a way of storage, that a typical way of storage. A typical way of storage, way of storage, so that using the existing technology, right? Now, one of the participants is asking, what is duality? Duality in the current context means, I was talking with respect to public and private key. So encryption means converting a message into a form so that others cannot understand it. It's like coding it. So encryption can be achieved using certain keys. So one of the ways is using public and private keys. So if I encrypt a message, then using public key, then it cannot be understood by any other one. But there should be a way to receive the original message back, which is called a decryption. So to retrieve the original message back, once it has been encrypted by the private key, we have to use public key. Similarly, you can use any of the keys, public or private key, for encryption. Encryption is a process. Encryption is nothing but a function will be there. You have to provide input to the function. Input will be some data which needs to be encrypted and a key. Now the key can be public or private. You can do encryption using public key or private key. If you do encryption using public key, then the way to retrieve data, which is called decryption, is you have to use private key. However, if you encrypt using private key, then you can decrypt using public key. So this is what I mean by duality. Duality means they are dual of each other. If public key encrypts, private key can decrypt it. If private key encrypts, then only public key can decrypt the message. So this is all about blockchain, basic technology behind blockchain. Now, briefly, we will discuss the application of the blockchain, where you can use blockchain in your research, or what are the prominent areas where government wants to use blockchain and you can get projects in the blockchain. So 10-15 minutes I'll take. Now, I will provide you a very, you can say you have to just see three things in an area if you want to apply the blockchain. First thing is, the parties involved should be autonomous or authoritative domain. Autonomous or authoritative mean that they can take their own decision. For example, what are the parties involved in Bitcoins? Bitcoins, the party involved are we users. We are autonomous. We can take decision on our own. We are free to transfer any money to anybody. We are even free to do any malicious thing. It is the Bitcoin system which is preventing us to act maliciously. So whenever you want to apply blockchain in any system, you have to first see who are the members of this system. These members should be autonomous, which are free to take their decision. And the second property which you have to see is that they do not trust each other. There is a trust deficit. For example, in the banking using Bitcoin, there is a trust deficit. between the members. I do not trust you that you will remain truthful. You will carry a truthful record. So whenever you want to apply blockchain, you have to see the deficit. And the third thing while applying blockchain is that you should see that they want to collaborate with each other to achieve a common goal. Right? So these are the three things you have to look before applying blockchain. You have a problem where members are autonomous, they do not trust each other, and they want to operate with each other to achieve a goal. For example, uh, uh, for example, right? So now the common example of the blockchains are it is being used in cryptocurrency, Internet of Things, energy trading, governance, healthcare, logistic, manufacture, media. Now time is very less, so I will just touch upon the two common applications of the blockchain. So that I'll share the slides if you are interested. It has my email ID. You can get back to me, but I'll just check. Just discuss two common examples. First one is cryptocurrency. Now, before talking about cryptocurrency, I want you to remember at least one thing from the presentation. You forget everything which we have discussed in the presentation. Just remember one thing. Blockchain is not Bitcoin. Most of the time people say that Bitcoin is blockchain is Bitcoin. They are using it in place of each other without understanding what it is. Telling that blockchain is Bitcoin is saying that internet is email. Internet is not email. Neither email is internet. Email is one of the most popular application of internet. Similarly, Bitcoin is not blockchain. Bitcoin is one of the most common application of the blockchain. Right? So now why blockchain is so common in cryptocurrency? Because whenever monetary transactions are involved, we need to have a secure record of the monetary transactions. Right? And secure record should not be temperable. So that is why we use blockchain in cryptocurrencies. So since time is left, I am leaving this. I'm not covering this. Now I'll come to the one more application of the blockchain, and I'm adding this application because it is very common to the problem that currently Punjab is facing. So there is a farmer agitation. I'm not saying it is correct or wrong. Farmers are correct or government is correct. Don't take me in that way. But what I'm discussing that we can use blockchain to improve the conditions of the farmer in our country, right? And before going into how blockchain can be used, can anybody tell me what is the significance of this red number 23 written in red? Can anybody tell me the significance of 23 number that I have written in the red font? Any ideas, participants? At least people from Punjab should know what is the significance of this 23 number for farmers. Any ideas, participants? Okay. 23 is the rough estimate of the number of farmers that are committing suicide daily in India. 23 farmers are committing suicide daily in India. So this is the significance. So this is the present condition of farmers in India. I'm not blaming anybody, but I want to I just have taken this example to clearly demonstrate the application of the blockchain. Now, why farmers are committing suicide? Because the output of the farmers or the crops farms is very less as compared to the loans that they are taking. We say that in India it is Jai Jawan, Jai Kisan. But we as a society have failed to deliver to farmers, right? And if we do not consider our farmers, our condition will be like China. Why COVID originated in China? Because in China, people shifted from farming to manufacturing and everything. So there was great famine in 1900s. People shifted from farming to other manufacturing circuit, manufacturing industry, software industry. There was nobody to farm, nobody to grow crops. So there was a great famine. So that is why people started. This is one of the reasons also that people started change their eating habits. They started eating bats, snakes, etc. They included these animals in their food chain. And because of this, coronavirus happened. So similar situation should not arise anywhere in the world. Take care of the farmers, right? So how blockchain can be used to take care of farmers? To increase the output of the farmers, we can go for the scientific methods, right? But the problem with the scientific method is they are very expensive, right? I'm taking a very common example like tractors. Tractors can be afforded easily in Punjab, but not in other parts of the countries, right? Use tractors for irrigation farming, then the yield of the crop will increase. But people do not have enough money to purchase the tractors or the modern machinery. So one of the solution is they go for fractional ownership. Fractional ownership means that 11 farmers own a single tractor. Why they go for fractional ownership? Because they do not have enough money to purchase tractor. So if we go for fractional ownership, then why are not people going for fractional ownership? The reason being that people are not reliable. Suppose 11 people decide that they will go for fractional ownership. So they purchase a tractor on loan. So they have to give monthly installments. So 10 give monthly installment on the time, whereas 11th one defaulted. So what will happen? All the 10 farmers will also suffer because of the mistake of 11th farmer. So that is why, because there is lot of the cooperation is not so easier. Similarly, another reason why people do not go for fractional ownership is, suppose I have the tractor is being shared by 11 people. So they have distributed this tractor usage time among 11 people. One of the farmer doesn't return the tractor on time to the other farmer. Suppose A doesn't return tractor on time to the B farmer. What will happen? The crops of B will suffer, right? So the B will be reluctant to go for fractional ownership. So that is why, because of the many problems arising due to cooperation, people are not ready to fractional ownership. Now, how blockchain can help here? Now, there is one part of a blockchain called fractional ownership. In fractional ownership, you can program all the things. If anybody defaults on its promise means to pay installments on time, to adhere to the usage time assigned to it. Anybody does not follow the promise, it will be penalized in the blockchain. There is a coding if-else condition. You have to write smart contracts, and this the person gets penalized automatically, right? So in this way, blockchain can be used to promote fractional ownership. This is also called Uberization of agriculture. Blockchain can bring Uberization of agriculture. So like Uber has drastically reduced the taxi fares, so similarly blockchain can drastically reduce the price it takes to employ new scientific methods in agriculture. So there are other applications of the blockchains also. I have discussed it in detail in the presentation. You can go through the presentation. I will share the presentation with the organizers. I have my email ID also in the presentation. You can get back to me regarding your doubts. Apart from that, if you have any doubt about blockchain, you can ask me now. I am ready to take your questions. So, any doubts regarding? Yeah, Vineet, you can say that cryptography is one of the backbone of the blockchain. And for the people who are from the EC background, they need not to go into the cryptographic domain, understand cryptography also if they are trying to implement blockchain. Because there are already inbuilt models of cryptography available like Ethereum blockchain in IBM blockchain, where you do not need to understand what actually how cryptography is being implemented. You just need to understand it will get encrypted. So don't, yes, cryptography is one of the important feature. But if you want to implement blockchain, you can do it without actually understanding nitty gritties of cryptography, right? So any other questions? So if there are no questions, again, I would like to tell you, repeat the same thing. Blockchain is like salt. If your paper is your food, actual food item, blockchain is like your salt. So if you're writing something, if you're solving some problem, if you attach blockchain with it, it will increase the flavor of that dish. So whatever problem you are solving, it will enhance the flavor. Okay. So I think there are not any more questions. So we should. So I'm ending this talk. So I'm sharing my presentation and my email address. Any issues are there? Please feel free to call, email me. Okay. So thank you everybody for being such a active participants in today's presentation. So,
Yeah. Thank you, Dr. Nitin. And if there's no questions from audience, this is already a very interactive session by Dr. Nitin, and he has already very kind to share his email ID. And if you have more questions, please feel free, as he already said, to email him, and I'm sure that your questions will be answered. So once again, I would like to express my sincere gratitude to Dr. Nitin for sharing his talk, valuable, informative talk, and it was really very informative and getting insight for the blockchain, particularly for me, and I'm sure same is with other audience also. So thank you, Dr. Nitin, for sharing your talk with all of us.
thank you.
Yeah, for participants, next session will be, I think you all have heard this schedule of this STC. So the next session is from 1:30, and speaker of the talk is Dr. Pawan Kumar Verma from NIT Jalandhar. I'm sure that the next talk will also be interactive, and all of you will participate with same spirit as we participated in these sessions. So once again, I thank the speaker and all participants for being with us in this session. Thank you very much. Yeah, attendance is being marked automatically. You please don't worry about the attendance. Uh, this Gmeet thing will automatically will mark your attendance, all the participants. Yeah, yeah. Dear participants, welcome to this session. So let us wait for the participants for some 2-3 minutes, and then very soon we are going to start next talk. Dear participants, once again I welcome all of you in this session. So this session is being delivered by Dr. Pawan Kumar Verma. Let us have a brief introduction of Dr. Pawan Kumar Verma. He received his B.Tech degree in Electronics and Communication Engineering from Agra University and M.Tech degree in VLSI Design from C.Tech Mohali in 2005 and 2009 respectively. He has worked as a consultant for 2 years at Cadence Design System Noida. He was a visiting research scholar at a University of Waterloo, Canada during April 2012 up to the October 2012. He did his PhD from Motilal Nehru National Institute of Technology, Allahabad in December 2016. And currently, Dr. Pawan is working as an assistant professor in the Department of Electronics and Communication Engineering at NIT Jalandhar. It's my privilege to introduce Dr. Pawan for this course. His area of interest research are machine-to-machine communications, MANET, WANET, wireless communication network, and mobile computing. Today, Dr. Pawan is going to deliver a talk on massive access control in machine-to-machine communications. So I welcome Dr. Pawan for this lecture, and over to Dr. Pawan. Thank you.
Thank you. Thank you, Dr. Satish, for this opportunity. I'm just going to share my PPTs. So my screen is visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
It's visible.
Okay. So, hello everyone. A very good afternoon to all of you. So today, my talk is based on the topic massive access control in machine-to-machine communications. So this is the outline of my presentation. First is the introduction of the machine-to-machine communication, where I will discuss about the system model of M2M, its communication architecture. Then we will see some of the existing as well as the potential M2M applications, their standard developing organizations, and a few open research challenges. Then we will see how the massive access control can be done in case of M2M communications using a medium access control protocol, a specific medium access control protocol for massive access control in M2M communications, followed by the references. So first is the introduction of what is M2M. So basically, the machine-to-machine communication is a new communication paradigm and is a promising technology for next generation communication systems. So what is happening here is there will be a large number of devices in terms of millions or billions maybe. They will be connected by some wired or wireless links, and they will try to communicate and share data with each other with a little or without direct human intervention. Right? This is the basic definition of M2M communication. Now, as a simplest example to know what is M2M, the simplest example is the GPS navigation system. Okay, so what happens in GPS navigation system? Suppose we are going on a certain road by our vehicle and we don't know the road map ahead, right? So what happens is, as soon as we keep our GPS navigation system on, then it directly communicates with the satellites to provide us the roadmap ahead. Okay, so this is M2M. This is the simplest example, one of the simplest examples to know what is M2M. In the same manner, if you see, if you connect your laptop or your computer system to the projector, right? Once you connect, then they can share data between themselves without any direct human intervention. The laptop or your computer and the projector, right? Once the connection has been established, right, the data will be shared between the two machines without any human intervention. So this is another example of M2M. So the next question is, what is the need of M2M? The need is to save both the time and money, right? As soon as the devices are interconnected, and as you can see in the definition of M2M, that there will be a very little, or there should be no direct human intervention. So as soon as this happens, it will save time and in turn money also. So as a result, it has already become a market-changing force due to its ability to support a number of ubiquitous characteristics and achieve better cost efficiency. Right? Now, its historical roots lie in supervisory control and data acquisition systems, which are called the SCADA systems, where sensors and other devices are being connected through wired or radio frequency networks and are used with computers to monitor and control the industrial processes. Okay? Its early phases took place in blue-collar activities such as fleet management and shipping containers. Right? And some of its existing as well as the potential applications include the smart grid, the remote e-healthcare, home automation or smart homes, the intelligent transportation systems, the environmental monitoring, and the smart city. Okay? Now, what is the system model of M2M communications? So this is the figure for the system model of M2M communication, and this figure includes 3 different domains in which the entire network has been divided. Okay, so the first domain is the M2M domain or the device domain, right? The second domain is called the network domain, and the third domain of the network is called the application domain, right? Now, if you see the M2M or device domain, what is happening here is different devices have been deployed in the field, right? All these ellipses are representing the different devices which have been deployed in the field, right? Now, together they form some M2M area network, right? And what they do is they sense some kind of physical parameters in the field, and they send this sensory information from this device domain all together to the application domain with the help of this network domain. Right? Now, if you see, then this is almost a similar system model which is also applicable to the wireless sensor networks as well as the Internet of Things. But there are a few slight differences among all these models. For example, if you compare this system model with the wireless sensor networks, then the difference is, you can see in this figure, all the arrows which are actually representing the communication between different devices are bidirectional, right? In this figure, all the arrows you are seeing are bidirectional. It means that the communication, in this case, in case of M2M communication, the communication is bidirectional in nature. Means it can be from the device domain to the application domain, and also from the application domain to the device domain, right? It is just because of the devices which have been deployed in the field have the ability to receive information, right? But this is not the case in case of wireless sensor networks. Although in the market now some specific sensors some specific sensors are available which have the ability to receive information also, but in general, we deploy sensors to sense some physical parameter and transmit this information, right? They generally, they do not have the ability to receive information. So in case of wireless sensor networks, all these arrows will be unidirectional in nature, right? The information flow will be from the device domain to the application domain for wireless sensor networks. But in this case, the information flow can be bidirectional. In case of IoT also, the information flow will be bidirectional, right? But the M2M communication and the Internet of Things, both these paradigms have their own differences also, right? The biggest difference between M2M and IoT is that an M2M system uses point-to-point communication, right? But on the other hand, an IoT system typically locates its devices within a global cloud network that allows large-scale integration and more sophisticated applications. Okay? Now, there is another difference between M2M and IoT, which is called the scalability. It means that the term scalability means to change, right? Now, here, the significance of this term is that in case of IoT, it is designed to be highly scalable, right? When we talk about the Internet of Things, then its system model is designed to be highly scalable. Why? Because the devices can often be added to a network and integrated into existing systems with minimal hassle, right? But on the other hand, M2M networks can be more labor intensive to set up and maintain, since new point-to-point connections must be created for each device, right? This is another difference between M2M and IoT. Now, one more difference is there, and that difference is, in case of Internet of Things, the devices which are trying to communicate with each other use the wireless technologies only, right? But on the other hand, M2M may or may not involve the wireless communication, as we have seen in the definition of M2M communication, that the devices may be connected by wired or wireless links. You can see here, right? But this is not the case in Internet of Things. The devices will use only the wireless technologies to communicate with each other. So these are few differences among all these communication paradigms: the wireless sensor networks, the M2M communications, and the Internet of Things. Now, these are some of the key radio technologies which are being used in M2M networks, but they have their own domain. All these technologies are being used here in M2M or the device domain, right? Because if you see, whatever standards I have mentioned in the leftmost column, they are the short-range communication protocols, to be specific, right? For example, the Wi-Fi, the 802.15.6, the ultra-wideband, the Bluetooth, and the Zigbee. They all are short-range communication protocols, right? Now, one more thing which I need to tell you is that in case of the M2M device domain, whatever communication is going on among the devices, it will use the short range communication, because the distances involved here in case of M2M device domain will be small. Okay, but as soon as the data is being transmitted from this device domain to the application domain with the help of this network domain, So when the network domain comes into the picture, the distances or the ranges will be in terms of kilometers, right? So in case of network domain, we will talk in terms of long range communication protocols, right? This is another point to be noted. In case of M2M device domain, the distances will be very small. The distances between the devices where they are located. But the distances involved in case of network domain will be very large in terms of few kilometers. So here we will talk in terms of long range communication protocols. For example, one of the long range communication protocols is called the long range radio or LORA protocol, where the coverage is near about 15 kilometers, right? Another long range communication protocol is called the SIGFOX. And in this case, the coverage will be near about 13 kilometers, right? But here I have only mentioned some of the short range communication protocols because in the subsequent slides, I will only talk about the M2M device communications. Whatever communication which is happening among the devices, I will talk about it only. I will not talk about whatever communication is going on between the device domain and the application domain. I'm not going to talk about that. Right? So keeping that in view, I have only mentioned the short range communication protocols in the leftmost column of this table. So in this case, the first standard is called the Wi-Fi, which can be used in local area networks. Their data rates have been mentioned here. For example, in case of 802.11a, it has different subsets or different protocols. This IEEE 802.11, and here I have considered 4 of them: the A, B, G, and N. Right? So for 802.11a, the data rate is up to 54 Mbps. And the same data rate is applicable also for 802.11g, right? But in case of 802.11b, the data rate is up to 11 Mbps only. And for 802.11n, it is near about 100 Mbps. In the same manner, what is the range? The range involved in case of Wi-Fi is up to 46 meters for indoor applications for the versions 802.11b, G, and N. Right? But in case of 802.11a, the range is 92 meters for the range is 1/3 of that is involved in case of 802.11 B, G, and N. Right? So for 802.11 B, G, N, for indoor applications, the range is 46 meters, and for outdoor applications, the range is 92 meters. Right? And their possible applications involve the smart metering and laptop connectivity. Okay? In the same manner, you can see I have summarized all the parameters which are associated with the corresponding protocols. Now we are going to see some of the existing applications of machine-to-machine communications. And here, the first application which I am going to talk about is the smart grid architecture. Right? So in this case, whenever we talk about the power grid, then there are 3 different stages in which the power is being generated and distributed. Right? And these stages are, the first stage is the power generation. You can see on the leftmost side, right? Then the power is being transmitted to some distribution substations from where the power is being distributed to some local area. Right? Now, among all these three stages, here we are only considering the power consumption side, and then we will map this architecture with the M2M communication system model. How? We will see. So, as soon as you start considering the power consumption side, what will happen here? There will be a few homes in a local area, for example, right? You can consider any local area where a few homes are situated, 10, 20, 50, etc. Right? Now consider a smart meter. A smart meter is being connected or deployed in each and every home. Right? So all these smart meters will be your M2M devices. You can map those smart meters with the M2M or device domain here. Right? Now, what will they do? The smart meters, they will measure the power consumption in each and every home, and then they will transmit this information to a concentrator. Right? Now, this concentrator is actually working as the gateway. You can map this concentrator with the gateways which have been shown in this figure in the M2M communication system model. Right? And from this concentrator, this information has been transmitted to a control center where a person will be sitting to analyze this information and take some decisions. Right? So the distances involved here between the concentrator and the control center will be in terms of few kilometers. Right? So what I mean to say is, in this case, the network domain is here between the concentrator and the control center. You can see here, you can map this smart grid application or architecture with the M2M communication system model. So if the concentrator is your gateway and the control center is your application domain, then the distances involved between both these domains is your network domain, right? And the smart meters which have been deployed in different homes are your M2M devices, right? So in this way, you can map each and every application of M2M with its system model, right? So in this case, we have only considered the consumption side of the power grid, right? We have started from here and gone up to the control center, and we have mapped the M2M communication system model with this application quite clearly. Okay. Now this is the second M2M application, which is called the home area network architecture. As you can see in this figure, what is happening here? Here, within a specific home, different devices are being connected through some kind of subnetworks, right? Now, what does it mean? The term subnetwork means the devices, the different devices which are within a home, which are situated or located within a home, are using some different kinds of protocols to communicate with each other, right? And all these subnetworks have been provided connectivity by this cognitive gateway, right? And ultimately, all this information has been transmitted from this cognitive gateway to some kind of external networks. For example, in this case, we can transmit all this information, the communication among all the devices, this information can be transmitted to the internet. Right? So these are your M2M devices which are using different subnetworks or different radio technologies to communicate with each other. And this information can be transmitted to any external network. So this is your network domain, the distance between the cognitive gateway and the external networks, right? And whatever external network you are using, for example, in this case, the internet, is your application domain. Okay. Now this is the third application of M2M communications, which is called the intelligent transportation systems, which can provide you the safer roads, more efficient driving. For example, in the first case, suppose you are going on a certain road and there is an accident ahead. So if the vehicle-to-vehicle communication is possible, then this information can be transmitted to the traffic which is coming from backward side, right? So they can take some alternate paths to avoid the jam ahead, right? In the same manner, if there is a congestion on the road, then this information can also be transmitted to the traffic which is coming from the backward side, so that they can again take some alternate paths to avoid the further jam on the road. Now, here some of the terminologies have been used. For example, there is an RSU, you can see in this figure, which is called the roadside unit. The roadside unit is nothing but a kind of an access point which will provide connectivity to all the passing vehicles, right? And the vehicle-to-vehicle communication will be possible with the help of an onboard unit, which is also called the OBU, which will be inbuilt within each car. It will have the ability to communicate with each other as well as with the RSUs, right? And in the back end, there will be a server where all this information can be stored, right? And which can be used for further applications, right? In the same manner, suppose there is a malfunction in your car and suppose some service center is ahead on the road, then you can transmit some prior information about the status of the car, how it is doing, and you can also transmit the time, the approximate time within which you can reach the service station, so that they will be ready to serve you, right? There will be no further delay, right? In the same manner, you can get some kind of software update, and the vehicle-to-vehicle communication can also be used for infotainment services. For example, if you can see in the bottom figure where the vehicle-to-vehicle communication is going on for some kind of infotainment services, for example, MP3 download, right? Or the movie download. This is also possible. So now these are some of the M2M applications, some of the existing as well as some potential M2M applications, their characteristics and their supporting attributes. I have summarized all these things into this table. So here on the leftmost column, you can see some of the M2M applications which I have already discussed. For example, if we consider the case of smart grid, then what should be the characteristics in this case? See, as we have already discussed in this lecture, that there will be a large number of devices which will be trying to communicate with each other, right? So this concurrent bulk device transmission will be there in most of the M2M applications. This is one of the characteristics, one of the possible characteristics in case of M2M communication. There will be bursty data traffic, right? Whenever there will be demand, the devices will transmit. Whenever devices are ready to transmit, means they have data to transmit, they will try to occupy the channel, right? Now, in case of smart grid, there is no mobility among the devices. Means once a smart meter has been deployed into a home or a house, it will be immobile. It will be fixed on a particular location. There is no mobility, which is in contrast with the intelligent transportation systems, where vehicles are trying to communicate with each other, but they are mobile in nature, right? So the nodes which are trying to communicate with each other in case of intelligent transportation systems are mobile in nature, but in case of smart grid, the nodes which are trying to communicate with each other are fixed on some particular location. And the low power consumption, right? Whatever measurement the smart meters are taking out of a particular home, they should consume a low power. This is another characteristic in case of smart grid. Now, from the column number 3 and onwards, these are the supporting attributes to the characteristics of these applications, right? For example, channel request and allocation is required in case of smart grid. What is channel request? Channel request means how the measurement, whatever measurement the smart meters are taking, how they will transmit this information to the aggregator and subsequently from the aggregator to the control center. For that purpose, if the smart meters are using some kind of wireless technologies, then for that purpose, they need to acquire channel first, right? Then only they can transmit. Okay, so the channel request and allocation is necessary in case of smart grid, right? Then comes the interference mitigation mechanism. Means there must be no interference. Means all the measurements from different smart meters must reach the aggregator as well as the control center separately. They must not be collided. So this is required in case of smart grid. Cooperative communication, right? It is again there to mitigate the interference and collisions, right? So these are some of the supporting attributes to the characteristics of M2M applications. Now, this is the classification of M2M data traffic, right? So again, in this case, on the leftmost column, I have summarized some of the M2M applications. And in the second column, I have summarized the packet length which is required for each specific application, what will be their transmission mode, and what will be the priority for the M2M data traffic for each specific application. For example, if you consider the first application, e-healthcare, which is mentioned here, in that case, the packet length will be short. By this term short, I mean that the length of the packet must be less than or equal to 1 KB, right? Their transmission mode will be periodic, right? The pattern will be periodic. The information will be sent again and again. And their priority will be high. Why? Because in case of e-healthcare, the data, whatever data has been generated, will be live sensitive data. So their priority should be high, right? So in the same manner, I have summarized the M2M applications and their transmission mode, their priority, and what should be the packet length for the M2M data traffic. Now, these are some of the M2M standards developing organizations, which I was talking about in the very first slide of my presentation, the outline of this presentation. These are some of the M2M standard developing organizations which are working to develop different standards, right? In the first table, table number 4, these standard developing organizations have been summarized. In table number 5, there are some technology driven alliances which have been summarized. And in this table, table 6, some of the application driven alliances have been summarized. So if we come to the first table, the standard developing organizations, the first organization is the 3GPP, which is called the third generation partnership program, right? Now, what is this model assumed? Model means the system model. So 3-tier architecture means there will be 3 different domains in the architecture of the M2M communication. What we have seen here, it involves the entire network of M2M communication involves 3 different layers or 3 different domains. So that is what I have mentioned here. The 3-tier architecture means 3 different domains, right? So in 3GPP or the third generation partnership program, the current standards work has delivered a term which is called EDGE, EDGE, which is called Enhanced Data Rates for Global Evolution, right? So the motive behind the EDGE design was to balance high-speed packet access, which is also called the HSPA coverage. The EDGE has improved spectral efficiency with reduced latencies down to 100 milliseconds approximately, and has also increased throughput speeds up to 1.3 Mbps in the downlink and 653 kbps in the uplink, right? In the same manner, you can see the second standard developing organization is the ETSI, which is called the European Telecommunications Standards Institute, right? So the ETSI standardization efforts take into account a wide range of security issues, basically, right? Such as cybersecurity, lawful interception of algorithms, electronic signatures, smart cards, and they relate to every aspect of information and communication technology. The third standard developing organization is the Internet Engineering Task Force, IETF, right? It again assumes, as well as ETSI and the IETF, they again assume the 3-tier architecture of M2M communication system model, right? Now, in case of IETF, a set of activities have been created which are related to smart objects such as 6LoWPAN and ROLL. ROLL means routing over low power and lossy networks, right? The aim of these efforts is to bring the internet protocol to M2M devices required for building and monitoring infrastructure for smart grid, right? Now, there is another standard developing organization which is called 1M2M, right? It assumes a 4-tier architecture, right? In contrast to the earlier 3 standard developing organizations, it assumes a 4-tier architecture. So in this case, if we talk about the task of 1M2M, then it is to create technical specifications addressing the requirement of a common M2M service layer between the network domain and the application domain, as we have already seen in figure 1, the system model, right? There will be another layer which lie between the network domain and the application domain, and this layer is called the M2M service layer, right? The purpose is to develop the cooperative optimization standards. The purpose of this additional layer. So in the same manner, I have summarized some of the M2M technology driven alliances, right? which you can see in this table 5, and some M2M application driven alliances, which you can see here in table 6. Right? In this case, you can see the short forms of the application driven alliances in the leftmost column. For example, if I talk about the TIA, it is called the Telecommunication Industry Association, right? Then comes the ITU, which is called the International Telecommunication Union, right? And their specific targets have been summarized on the rightmost column. So you can go through them just like I have described all the model assumed and their specific targets in case of standard developing organizations. Just like that, you can go through them. Right? Now this figure actually shows which specific standard developing organization is working where in the system model of M2M communication. Right? In the background, there is a figure of M2M communication system model, and these boxes, these dialog boxes are showing the different standard developing organizations which are working to develop different standards for M2M communication. I have just summarized them in the previous PPTs. Now, these are some of the open research challenges which are related to M2M communication. Okay. So whatever I have discussed till now in this lecture is a survey on M2M communication. And these are some of the open research challenges which came out of that survey, right? These are the some of the specific problems on which you can work in your research. So as an example, how to carry your research work for a particular problem, I have considered this problem massive access control, right? So further on in this lecture, we will talk about it. How the massive access control can be done in case of M2M communications. Right? So now, to start with, we know that in interference-rich and noisy environment, wireless communication is often hampered by some unreliable communication links. Right? Now, the major obstacles in wireless ad hoc networks are the signal fading, which is due to the communication environment, the dynamics of the channel, right? And the second one is the interference due to the presence of some other devices. These are the major obstacles in wireless ad hoc networks. Ad hoc networks means the temporary networks which come into existence based on the demand, and as soon as the demand is fulfilled, the networks will vanish with respect to time. They are called the ad hoc networks, right? Now, the network capacity is determined by the underlying medium access control and physical layer protocols. Okay? Now, coming on to the definition of the M2M communication, where I have told you that there will be a large number of devices which will try to communicate and share data with each other without any human intervention. So with such a large number of devices, the medium access control layer issues in M2M communications are, what can be the issues at MAC layer? The first issue is the contention among such a large number of M2M devices for channel access. See, if you have gone through the subject, the computer networks, right? If you have gone through any of the books which are related to computer networks, then in those books, you can find a chapter on this medium access control protocols. So if you know by this term, the medium access control, I mean to say is, there are two different scenarios. The first scenario can be there is only one transmission at the transmitter machine and its corresponding receiver machine. When there is a scenario in which there is only one transmitter and a receiver, then there will be no problem, right? It can easily access the channel and transmit its data to the corresponding receiver device. There will be no problem. But as soon as the number of transmitter devices increases, right? If we assume that the receiver device is only one, but the number of transmitter devices is increasing. Suppose there are 10 number of transmitters and only one receiver. Now, how will you decide then who will acquire the channel first, who will acquire the channel next, and so on? There will be a bottleneck, right? So that's why the first issue is there. There will be a contention. Contention means fight. There will be a fight among different M2M devices for channel access. These devices are basically the transmitter devices, right? All those devices which are ready to transmit, there will be a fight among them for channel access. And as soon as the channel is acquired, we have fixed this issue, then what should be the data transmission mechanism for M2M communications? This is the next issue, right? So now, if we talk about the medium access control protocols, then they are categorized in two different categories, right? The first category is called the contention-based MAC protocols, and the second category is called the reservation-based MAC protocols, right? So if we talk about the contention-based MAC protocols, then it has some advantages as well as disadvantages, and the same applies to the reservation-based MAC protocols also. Both these kind of protocols have their own advantages and disadvantages. So in case of the contention-based MAC protocols, what are the advantages? Again, I am saying that any of you, if any of you has gone through the subject computer networks, then in the chapter, the medium access control protocols, you can see there are a number of contention-based MAC protocols which have been discussed. For example, you might have heard the name of Aloha, the Aloha protocol, the slotted Aloha protocol, the carrier sense multiple access protocols, CSMA, right? All these protocols are the contention-based random access medium access control protocols. And the advantages of such kind of protocols are they are simple, flexible, and incur low overhead. Low overhead means, what is overhead here? The term overhead means the transaction or transmission of some control packets before the actual communication, right? So in case of contention-based MAC protocols, there are low overhead, means there is virtually no control packet exchange, right? All these kind of protocols, for example, Aloha, slotted Aloha, CSMA, all these kind of protocols facilitate all the devices to access the channel, right? If you see, if you can recall, what is the working of Aloha? In case of Aloha protocol, if some of the transmitter stations have data to transmit, what they will do? They will not sense the channel. As soon as they have the data to transmit, they will transmit the data on the channel, right? So if the number of stations, number of transmitter stations is high, then there is a high probability of collision, right? And that's why the efficiency of Aloha protocol is very less. It is nearly 18%. So that's why its modified version came into existence, which is called the slotted Aloha. In case of slotted Aloha, the protocol is being divided into different time slots, and each transmission begins at the start of a time slot. So in this manner, number of collisions can be controlled, right? In case of slotted Aloha. So when the efficiency was calculated, then the efficiency of slotted Aloha came out to be nearly double to that of Aloha protocols, right? But in case of CSMA protocols, means carrier sense multiple access protocols, what happens is, as soon as a station has data to transmit, then it will first sense the channel and then it will take the decision. Means if the channel is busy, it will defer to transmit, right? But if the channel is idle, then it will start transmitting its data. So further, the number of collisions will be reduced in this case, the CSMA protocols, right? Now they have their own classification, means there are 3 different types of SISMA protocols. The first protocol is called the one persistent CSMA. The second protocol is called the non-persistent CSMA, and the third protocol is called the P-persistent CSMA. Right? They have been further classified into 3 different categories. So all these protocols have these advantages which I am talking about. The devices can join or leave the network dynamically without any extra operations. Right? If you can correlate this sentence, the third sentence in the advantages category, the devices can join or leave the network dynamically without any extra operations. Then which of the M2M applications can be related to this sentence? The devices can join or leave the network dynamically. So if you can recall, the intelligent transportation systems application can be correlated with this sentence. The devices can join or leave the network means the nodes or the machines or the devices which base MAC protocols are, as the number of devices attempting to access the channel increases, the number of transmission collisions also increases. Right? That's what I have talked about just now. In case of Aloha, in case of slotted Aloha, and in case of SISMA protocols, the number of collisions will increase as the number of devices increases. Right? And as a result, it will decrease the network throughput as well as the network lifetime. Right? The second disadvantage is they are not suitable for high density networks. Right? The discussion ends here. If they are not suitable for high density networks, then if you can correlate this with the definition of M2M communication, where there will be a large number of devices. So the point is clear. These kind of protocols, the contention based MAC protocols, are not suitable for M2M communication. You cannot use them alone because in this case, a high number of devices will be involved, and as a result, the collisions will increase, which will further decrease the network throughput. And the third disadvantage is the idle listening requires as much energy as it does while receiving data. Right? Idle listening means the transmitting station or the transmitting device is only listening to the channel or sensing to the channel. It is not transmitting. Right? So this action requires the same amount of energy as it does while receiving the data. Now comes the second category, of the medium access control protocols, which is called the reservation-based MAC protocols. They also have their advantages and disadvantages. The first advantage of such kind of protocols is they mitigate or alleviate the interference, right? As the name suggests, you can yourself see the name is reservation based, right? So what I mean to say is, as soon as the channel is acquired by a particular device, then the channel is reserved for that device for a particular time. Now, reserved means during the transmission, no other device in the proximity of the transmitter will interfere. Right? So in this manner, it resolves the hidden or exposed terminal problems. Right? But as we have seen in the earlier case, these kind of MAC protocols also have their own disadvantages. For example, the first disadvantage is the non-scalability. Right? The reservation-based MAC protocols are non-scalable in nature. Okay, they are fixed. There are a fixed number of slots available for the devices. Right? For example, if we consider the time division multiple access protocol, right? There are a specific number of slots which are there for different transmitters. So each transmitter which will have its own slot, its own time slot to transmit the data, and during that time slot, no other device in the proximity of that transmitter will interfere. Right? Now, the second disadvantage is the need of a centralized device or an access point to provide a collision-free schedule. Okay, we need some kind of infrastructure to provide a collision-free communication in this case. The third disadvantage is creating an efficient schedule with a high level of channel reuse is very hard. Right? Strict requirement of clock synchronization, as in the case of TDMA, and managing dynamic topology changes is costly. Right? So, why I have discussed all these advantages and disadvantages of both kinds of MAC protocols? To have an idea about how we approach towards a solution for this. Right? So, now you must correlate all these advantages and disadvantages of both kind of medium access control protocols with the definition of M2M communication. Then you will be able to find out or to have an idea about what should be the possible solution for this problem. The definition of M2M communication includes a large number of devices, right? So as soon as a large number of devices are there, then the contention-based MAC protocols will not be applicable. You can see here. They cannot be used alone, right? But at the same time, the reservation-based MAC protocols also are non-scalable in nature, right? So what is the solution? The solution is a hybrid MAC. Means taking advantage of both kinds of MAC protocols, and at the same time, we should try to nullify their weaknesses. Right? So, what solution should be there? You can see the solution in this figure. Right? These are the frames. These are the different frames which actually contain some different time slots. Right? The first time slot which a frame contains is called the contention notification interval. The second time slot is called the contention interval. The third time slot is called the time slot announcement interval. And the fourth part of a frame will be the data transmission interval, which again consists of different time slots. Right? Now, if you see the second and fourth part of these frames, they are contention interval and data transmission interval. Right? So, for contention interval, we are using the P-persistent CSMA protocol. And for data transmission interval, we are using the time division multiple access protocol. Right? So, that's what I have mentioned here. What will happen is, see, here I have mentioned both the issues with the MAC layer protocols in case of M2M communications. Contention will be there among the M2M devices to access the channel first, and as soon as the channel is acquired, what should be the data transmission mechanism? These were the issues in the MAC layer of M2M communications, right? So, if we correlate this frame structure with the issues of the MAC layer protocol, then the picture becomes clear, right? So, for the contention interval, we have chosen the P-persistent CSMA protocol, and for the data transmission interval, we have chosen the time division multiple access protocol. Right? Now, where does a frame comes from? From where a frame comes from? So the answer lies in the M2M communication system model. I am talking about only the M2M device domain, which consists these M2M devices which are being deployed in the field up to the gateways. Right? This is your M2M device domain. Right? So, my question was, from where a frame comes from? So, the answer is, the gateway will transmit a frame to all the devices which are within its vicinity range. Right? The gateway will originate and transmit the frames to all the M2M devices which are within its proximity range. So, in this figure, these frames are coming from the gateways, right? Now, these are the time division multiple access time slots, which you can see here, S1, S2 and up to Sn, right? These are the TDMA time slots, and within each time slot, I have assumed that each M2M device is IEEE 802.11 protocol enabled, so that there will be a four-way handshake mechanism, right? Before the actual data transmission, there will be an exchange of some control packets, and as soon as the data is being transmitted, an acknowledgement will go from the receiver to the transmitter device, right? So this is to be remembered, that each M2M device in this case is IEEE 802.11 protocol enabled. Why we have taken this assumption? Because most of the devices which are existing nowadays, they have the IEEE 802.11 specifications, right? So that's why our assumption is valid for most of the products, for most of the communication products. Now, this is our system model, right, which we have taken from, or which we have considered for the smart homes, right? This is the gateway which provides connectivity to all these sub-networks, right? And these are the different devices, right? The network consists of heterogeneous devices which have different abilities to communicate. But here, our assumption is all these devices are 802.11 protocol enabled. so that all the subnetworks will be 802.11 subnetworks. Right? So this is our assumed system model for smart homes or any other M2M applications in which the devices are immobile or fixed at their positions. So this I have already covered, the system model, the assumed system model. Now, here comes the massive access control analysis, right? So here, the total number of M2M devices in the network, we assume that to be equal to capital P. The number of active devices trying to access the channel is capital Q, and the number of successful devices during contention will be R. You can understand it with the help of this figure, right? I have told you that during the contention interval, we will be using the P-persistent CSMA protocol. So what will happen here? As soon as the contention notification interval is being received by the different M2M devices from the gateways, what will happen? The machines or the M2M devices will contend for the channel access during this contention interval using the P-persistent CSMA protocol. Right? How the contention will be there? The different M2M devices will transmit some small transmission request messages to the gateway. They will request the gateway to have the access of the channel during this interval, the contention interval, right? And during the time slot announcement interval, the gateway indicates by this time that this is the end of the contention interval and it is the beginning of the data transmission interval, right? It is an indication of this phenomena to the M2M devices, right? So during the contention interval, some of the M2M devices will succeed in acquiring the channel and some of the M2M devices will fail to access the channel, right? So all those devices which have acquired the channel will be given different time slots during the TDMA time duration or the data transmission interval, right? S1, S2 up to Sn, these are different time slots which will be assigned to different M2M devices which have acquired the channel or succeeded during the contention interval. Okay? So that's what I'm talking about here. The total number of M2M devices in the network is equal to P. You can correlate this with this. Suppose these are the total number of M2M devices which have been deployed in the field, which is equal to capital P, right? Now, out of these M2M devices, some of the devices will not be ready to transmit the data, right? Means they have no data to transmit. While at the same time, some other machines or some other M2M devices will have the data to transmit. So we have considered those devices as active devices and the number of such devices is equal to capital Q, right? Now, among these Q devices, only R number of devices are those which have succeeded during the contention interval. Means they have reserved their time slot during the TDMA time slots. See, here, the number of successful devices during contention is equal to R. Now, the devices use P-persistent CSMA for channel access. The length of the message is a random variable, capital L, with average, small l. Right? The length of the message. Which message? During the contention interval, the devices will transmit some small transmission request message to the gateway. Right? They will request the gateway to provide them the channel access. That message length is a random variable, capital L, with average, small l. Right? So capital L values always correspond to an integer number of slots. Okay. Each device having packets ready to transmit will attempt to transmit with a probability small p, right? We are using a p persistent CSMA. Okay. The channel between two consecutive successful transmissions is considered to evaluate the channel utilization, capital U. Okay. And Ti, small ti, is the time between the consecutive successful transmissions, and small di is the duration of ith successful transmission. Okay. So these are some of the assumptions which we have taken for the massive access control analysis. And now the channel utilization can be defined by equation 1, right? Limit n tends to infinity, d1 plus d2 and so on, divided by t1 plus t2 plus t3 and so on. Or we can represent the same equation by equation number 2, where ed is the average duration of a successful transmission and et is the average time between two consecutive successful transmissions during contention interval. Right? Now, there is another parameter which we have taken into account, which is called the NIC, which is the number of collisions occurring during the time interval Ti. What is Ti? You can see in this figure, figure number 9, the collision and idle times. Right? So we have considered this as Ti, which includes the idle times, right? The successful data transmission, the collisions, and the next idle time, right? So Ti will be equal to this much as defined by equation number 3, and you can understand this equation with the help of this diagram, right? And I have also summarized the terminology involved in this equation and their specific meaning, right? So now what we are doing is we are trying to calculate the time period for the contention interval. This is the target first. So for that purpose, we need to calculate TCI. TCI has been assumed to be the duration of the contention interval and will be equal to this much. Summation of I is equal to 1 to R Ti plus Li, where Li is the request message length. Right? Now from equation 3, we can have the value of Ti, which can be replaced in equation number 4, so that we get the equation number 5. Right? Now, if we assume that E of TCI is the average duration for R number of successful contentions, to obtain the closed form expression of TCI, we need to derive this, right? The average duration for R number of successful contentions. So as soon as I say it an average duration, then what should I do? The equation number 4 should be divided by the total number of qualified devices which have acquired the channel during the data transmission interval, right? So we can obtain the equation number 6. So with some algebraic manipulations, we can write equation number 7 out of equation number 6. And here in this equation, I have mentioned the meaning of each and every term. For example, ENIC is the average number of collisions during Ti. E idle is the average duration of idle times. E collision J is the average duration of collisions given that a collision occurs, right? And ELI is the average duration of request messages during Ti, right? Now, to maximize the channel utilization, which is represented by Umax, right? we should optimize the equation of ETCI, which has been obtained in equation 7, right? And that can be done by obtaining the values of P, small p, which is the contending probability, and capital Q, which is the total number of active devices in the network. So that we can have the equation number 8, right? Now, in this equation, why I have written this minimum P belongs to 0 or 1? Because small p is the contending probability of a transmitter, right? Now, why I have minimized the value? The reason is, as the number of devices will increase, the contending probability will decrease. That's why I have written this equation number 8 to optimize the value of ETCI. Now, according to one of our references, we can have the expressions for different parameters which have been used in equation number 8, so that we can obtain the equation number 9, which comes out for TCI, which is actually a function of the total number of devices which have acquired the channel during the data transmission interval, capital R, and small p, which is the contending probability, right? So the purpose of this entire exercise is that from this equation number 9, it becomes clear that the values of both TCI and TDTI are not fixed and can vary based on the values of total number of devices which are successful during contention, which is capital R, and the value of contending probability, small p. Right? It is quite obvious that during the contention interval, if the number of M2M devices is quite large, then this interval can extend up to some more time, so that the data transmission interval will be less. And on the contrary, if the number of devices during contention is less, then this time duration can shrink further, so that the data transmission interval will be extended further. It will be large, right? So what I mean to say is, the durations, both these durations cannot be fixed and can vary on the basis of the values of total number of devices which have acquired the channel, that is R, and the value of contending probability P, small p. Now, how can we study and evaluate the performance of such a network? For that purpose, we have considered the 3 different performance metrics, which are throughput, the average transmission delay, and the channel utility. Right? Now, this entire scenario, which scenario? This scenario. This entire scenario has been simulated on the network simulator. It is called NS2 on Ubuntu 12.04 long-term support platform. Okay? And these are some of the simulation parameters, right? Most of these parameters have been taken as the standard values which have been fixed in case of NS2, right? For example, what should be the time slot assignment interval, its length, the frame length, the entire frame, what should be the time duration, which is 1500 millisecond in this case, the length of transmission request message, that should be like this, right? And so on. The value of control packets, the RTS packet, the CTS packet, the acknowledgement packet, we have taken all of them as equal, right? The value of data packets can be different, right? These are control packets and we have taken the size as equal. Now, this was the entire frame, right? and within each time slot during the data transmission interval, we had assumed that each M2M device was IEEE 802.11 enabled. So there will be a four-way handshake mechanism whenever a transmitter transmits its data to its intended receiver, right? So whenever it happens, then the entire phenomena can be described with the help of this diagram, right? The source M2M device is this, and the receiver device, the corresponding receiver device is this, right? So first of all, as soon as an RTS packet is being transmitted from the source device so that it can check the destination device, if it is ready to receive, then after short interframe spacing, the receiver device will respond with the help of this CTS packet. RTS means ready to send and CTS means clear to send, right? It will respond with the clear to send packet, and it will be an indication that I am ready, you can transmit your data. So further, by another short interframe spacing interval, the source M2M device or the transmitter device will transmit the data, and after having another SIFS time duration, the receiver device will respond with an acknowledgement packet. So all this phenomena will take place within a single time slot, S1, S2, S3, and so on. Right? Now, the packet length of all the control signals, RTS, CTS, and acknowledgement are same. We have already assumed. So we can write this: TRTS is equal to TCTS is equal to T acknowledgement. Right? Now the duration capital T of a time slot is equal to the sum of RTS packet length, the CTS packet length, the data packet length, acknowledgement packet length, and 3 maximum propagation delays. You can understand this line with the help of this figure. See, within each TDMA time slot, it may be S1, it may be S2, it may be S3, right? Within each TDMA time slot, there is a 4-way handshake mechanism, right? So each time slot contains a time duration of RTS, a time duration of CTS, a time duration of data, a time duration of acknowledgement, and 3 SIFS durations, right? So we can write the length of a time slot, capital T, as TRTS plus TCTS plus T data plus T acknowledgement plus 3 T SIFS, right? This is your equation number 10. Now, the length of a subslot during one time slot, we have taken it as TRTS plus TSIFS. This is one of the subslot of a particular TDMA time slot, right? Now all the transmissions commence at the beginning of each time slot having length T data. Okay? So as the number of users in an M2M network is very large, the data sessions arrival can be assumed to be a Poisson source having arrival rate lambda. So from equation 10, we can arrive at equation number 11 with the help of these assumptions, where the normalized traffic load G and L will be equal to lambda multiplied by T data. Right? So the probability of an RTS packet being sent is defined by equation number 12. This is nothing but a formula from the traffic engineering, but in that formula, we have chosen our own parameters, which have been defined as equation number 12. Now, an average successful transmission interval is of duration T data plus 3 times of TRTS plus TSIFS. Why we have taken 3 times? See, SIFS appears 3 times within each time slot. P, the first SIFS, the second SIFS, and the third SIFS. And as we assume the lengths of RTS, CTS, and acknowledgement packets to be the same, that's why we have written this equation number 13. Right? So an average successful transmission interval will have this much of duration. Now, the average number of slots a busy interval contains is, this is again from the traffic engineering, but we have taken our own parameters here. So small l will be equal to e to the power lambda multiplied by T RTS plus T SIFS. Now we define a busy interval containing successful transmission intervals, right? So its expectation or probability is defined by capital B, which is equal to small l multiplied by T success multiplied by P success, right? So if we replace all the values of all the parameters in equation number 15, we can have this equation, equation number 16. Now, in the same manner, each successful slot represents data traffic for T data seconds, right? So its expectation or probability is defined by equation number 17, where U is equal to small l multiplied by T data multiplied by T success. So if we replace the values of all the parameters in this equation, we can obtain the equation number 18 for channel utility, right? Channel utilization. Now, the throughput can be defined as the throughput per time slot, S is equal to U upon B, which comes out to be equation number 19, right? Now, the throughput during DTI, you can obtain throughput only during the data transmission interval, because the actual data transmission begins only during this transmission, this time period, the DTI. In the contention interval, the devices were fighting for the channel access. So that cannot be considered during the analysis of the throughput of the network, right? So we are considering the throughput only during the data transmission interval. So SDTI will be equal to the throughput per time slot multiplied by the number of devices which have acquired the channel, right? This is your equation number 20. So now we can calculate the throughput of the M2M network during each frame as S frame is equal to S DTI upon T frame, right? So if we replace the values of S DTI and T frame in this equation, we obtain the equation number 22. This is the throughput for the complete frame, right? Now in this equation, if you see, you can have an idea about, in case of numerator, there is a term T data, and in the denominator, all the parameters are nothing but some kind of time intervals. So they can vary, but this number, the capital R, it represents the total number of devices which have acquired the channel. This can change linearly, right? So now when we simulate the scenario of our system model on NS2, we get these results. Now in the first case, capital R is 10% of Q, means all those devices which have acquired the channel are only 10% of the actual active devices, right? The second case is for R is equal to 30% of Q, and the third case is for R is equal to 50% of Q, right? So in all these graphs, the red graph is showing the performance for TDMA. The blue graphs are showing the performance of slotted aloha, and you can also replace it with the P persistent CSMA. They will be similar. The nature of the graph will be similar in case of P persistent CSMA also. And the third graph, which is your green graph, is for the hybrid MAC, which we have implemented on the network simulator. Right? So you can see in all the cases, for example, if we consider the first case, what is happening here? In case of some reservation-based MAC protocols, for example, we have considered here the TDMA MAC protocol. The graph increases linearly with the increasing number of devices, right? But at the same time, if we talk about some contention-based MAC protocol, for example, here we have considered the slotted aloha, or you can also consider the P persistent CSMA, right? So for that condition, what is happening here is initially when the number of machines are up to 150, you can see here, the graph is rising, right? But as the number of devices further increase, what is happening? The throughput is declining. Why? Because the number of collisions are increasing, right? But now, if we see about the performance of the hybrid MAC, which we have implemented on NS2, you can clearly see that as the number of devices are increasing, right, the graph is also increasing linearly. But after the devices, the number of devices are crossing the mark 400, what is happening? The graph is declining gracefully. Why? It has its own reason. Why it is happening? It is happening because as you increase the number of devices, what will happen? During the contention interval, if the number of devices increases, there will be more number of collisions. So lesser and lesser devices will be able to acquire the channel during the data transmission interval. So that's why the performance of this protocol degrades after this mark, when the total number of devices is 400, right? Now, the second performance metric is the average transmission delay, which can be defined as the time elapsed between the start of a frame and the end of its transmission to the corresponding receiver device. So if we consider the T delay as the average transmission delay, then T delay will be equal to T contention notification interval plus T contention interval plus T time slot assignment interval plus T data, right? This is your equation number 23. Now, if we assume that NS is the number of slots during the data transmission interval, TCS is the time elapsed in control signal exchange between one hop M2M devices. Why one hop? Because the MAC protocols only talks in terms of one hop communication links, right? So in our system model, which we have simulated on NS2, we have assumed that all the devices are located one hop away only. Then only the communication will be possible. Now, T data is being assumed to be the time elapsed in data transmission between one hop M2M devices, right? So then we can write equation number 24, T DTI, the data transmission interval will be equal to NS, the number of time slots during DTI, multiplied by TCS plus T data plus T acknowledgement plus T SIFS, right? So this is the performance which comes out for all the three types of MAC protocols, the contention-based MAC protocols, the reservation-based MAC schemes, and the hybrid MAC. So you can see in this case also that the hybrid MAC protocol the performance of this protocol remains quite close to the reservation-based MAC protocols. The delay is almost similar, right? But the average transmission delay in case of contention-based MAC protocols is quite high in all the three cases, right? As the number of devices which have acquired the channel increases, then the delay is also increasing in case of contention-based MAC protocols, but the reservation-based MAC protocols as well as the hybrid MAC protocol performance in this case is quite similar. And the third performance metric is the channel utility, which we have taken into account, and it can be defined as the ratio of transmission interval TDTI to the frame interval, the complete frame interval T frame. So the channel utility is defined by equation number 25, and if we replace the values of different parameters in this equation, we can find the final equation of the channel utilization as equation number 26. And if we draw the graph for this performance metric, then it comes out to be like this. In this case also, you can compare this graph with the graphs of the throughput, and you will find quite similarity between both these graphs, right? All these linear graphs are for the reservation-based MAC schemes. All these curves which are declining as the number of devices are increasing are the graphs for contention-based MAC schemes, and all these high peak graphs are for the hybrid MAC protocol, right? It is quite clear from these graphs that the hybrid MAC protocol clearly outperforms both types of other MAC schemes, which are contention-based MAC and the reservation-based MAC schemes. So this is the conclusion of this entire analysis. Here we have focused on the massive access control mechanism for a densely deployed ad hoc M2M network, right? We have designed a novel hybrid MAC protocol for inter-M2M communications, which combines the advantages and at the same time offsets the disadvantages of P-persistent CSMA, TDMA, and IEEE 802.11 DCF mechanisms, right? DCF means distributed coordination function. We have analyzed the different key parameters such as network throughput, average transmission delay, the channel utility, and simulated the system model on NS2. And the results show that the hybrid MAC protocol outperforms the slotted Aloha and TDMA mechanisms in terms of aggregate throughput, average transmission delay, and the channel utility, as we have shown in the graph. Now, these are my references. Do you have any questions? Please, you can ask. All the participants, I request if you have any questions, you can ask. Please feel free to ask any questions.
Sir, I have a very basic question. If someone wants to get into this network research, what are the tools that you recommend that one should learn just for starting phase?
Sir, there are a number of different simulation tools which are available, but they are easily categorized into the license-based tools and some of the freewares or some unlicensed tools which are available freely on the net. So I will recommend to go for the license-free simulation tools. For example, I have used the network simulator, which is freely available on the net. Why I am recommending it? Because in case you are using some licensed software, then you are dependent upon the infrastructure or the facilities which are available in a particular institute. As soon as you pass out of the institute, you will not have that facility. So I will always recommend for all the freewares or some unlicensed simulation tools which are freely available on the net. So that's why I have using myself the network simulator. Its installation steps as well as how you can create some communication scenarios and how you can implement a particular protocol. They can be done by using some online available tutorials, which I can again suggest if anyone wants.
Okay, sir. Thank you so much.
Participants, do you have any questions?
Excuse me, sir.
Yes.
Which NS version is best suitable for this scenario implementation?
I have implemented this protocol, the hybrid MAC protocol, on NS version 2.35. Right? So I can suggest that 2.35 is quite good for implementing such kind of scenarios as well as such kind of protocols.
Okay, thank you, sir.
Okay, I assume that all the participants, they have quite understood this presentation. That's why I think there is no further question. So whenever in the later stages, if you have any doubt or any question, you can always reach me by mailing me. My email ID, I am giving it to you. You can always send your queries on this email ID. Thank you very much.
Thank you so much, sir. One update regarding tomorrow's presentation. Tomorrow's presentation will start at 9:30, and the first talk will be of Dr. Arjun, and he will be giving his talk on RF circuits and RF filters. Thank you.
Thank you, sir. Thank you all for providing me this opportunity, and I wish all the success to this short-term course. Thank you.
Thank you, sir.